Good morning, student. The fourth problem which which I am going to demonstrate is a problem on trusses. You can see this is a truss made up of 4 elements, and at the first node and fourth node is completely fixed, and at the second node it is free to move in x direction, where it is completely fixed to translate in y direction. And a load of 5 kN is applied at the second node, and a load of 10 kN is applied at the third node. We will go ahead and solve this by using software. Preferences, structural, okay. Preprocessor, element type, add element, add, link, okay. Close, material properties, material models, structural, linear, elastic, isotropic. The Young's modulus is 75 GPa, 75 E power 3. 0.33 is the Poisson's ratio. Say okay. Close. Sections, add 1. Say okay. The area of cross section is given as 100 mm square. 100. Say okay. Modeling, create nodes in active coordinate system. First node at the origin, say apply. Second node is at a distance of 100 mm, apply. Third node is at a distance of 100 mm, and in y direction 75 mm. X coordinate is 100 mm. Say apply. Fourth node is at x coordinate is 0, y coordinate is 75. Say okay. We have created 4 nodes, and we need to create the elements auto numbered, 2 nodes, first and second. You can click the right mouse button, center mouse button to create the element. Second and third, scroll button. Third and fourth, scroll button, and first and third. Say okay. Now we need to define loads. Define loads. Apply structural displacement on nodes. First node and second node is completely fixed in all directions. It cannot translate in any other direction. Say all degrees of freedom. Say okay. Nodes, second nodes, okay. It is free to translate in x direction, so y and z has to be fixed. Say okay. Now we need to apply the force or moment on nodes. Say okay. I also request you to, while solving this type of problems, you can take a problem numerical from your book and solve and compare the results. This force F is in negative y direction, minus 10 e power 3. Say okay. Select nodes, second node, say okay. And there is a force in f of x direction, 5 kN, 5 e power 3. Say okay. Solution, solve, current load step. Say okay. Solution is done. General post processor, element table, define table, add. We need to find the stresses by sequence number. SMI line element stress, LS1. You can call it as stress. We are calling it here stress. Apply. We can also find the reaction strains, the reaction forces. Apply. Also strains induced, LEPL, LEPL1. Say okay. Close. Plot results, line element results, stress, okay. These are stresses induced. Maximum stress is induced in element number 1 of magnitude 50 MPa. Similarly, we can see the reaction forces. Not node I and node J. Say okay. These are the reactions. 5000 kN. If you want to see it in numbers, list result. If you want to see the deformations happening in nodal degrees of freedom, say okay. At node 1, which is completely fixed, x displacement is 0, and at node 2, the x degree of freedom displacement in x direction is 0.66 in 10 ⁻⁻⁴ mm. Similarly, node 3 and node 4, you can also see the y degree of freedom, say y say OK. This is the y degree of freedom, y displacement. Okay. This is about your truss problem. Obviously, by clicking styles, size and shape, you can view it in 3 dimensions. Thank you.